equals what? True. True, huh? How about a suggestion? What could we do, Colin?
Would you square both sides?
We are going to square both sides.
Take the tangent to the other side.
But before we square both sides, let's take one of the functions to the other side. So we're going to move the tangent to the other side. So we're keeping the secant, and then we're going to have 1 minus tangent. So that kind of isolates your two functions. It gets one on one side, it gets one on the other. And then, as Colin said, we are squaring both sides. But when you square both sides, you can't just be like square, 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 which I saw some people do. It doesn't square like that. You're squaring a quantity because they're connected together as a pair with that addition sign. So you have to square the whole thing, which means if you're squaring the whole thing, you're really multiplying it by itself. And over here, we're squaring this as well. So now we have secant squared. When you FOIL this, you get 1 minus 2 tangent, and then a plus tangent squared. Oops, I only wrote t. So Lauren, what is the secant squared equal to? Yeah, secant squared is 1 plus tangent squared. So the whole goal of squaring both sides is so that you can then directly use an identity. And we can use 1 plus tangent squared. On the other side, we have still this same piece. And then what happens next? What do? After you, combine your like terms, set it equal to 0. This one works out really nicely because when you combine like terms and set it equal to 0, what do you have left?
No, it's 1. Or it's just 2 tangents.
It's just, so if I subtract 1, and we subtract tangent squared, you end up with just negative 2 tangent x, which is kind of nice. A whole bunch of stuff canceled. So we are actually saying, when is the tangent equal to 0? Remember, tangent is y over x. So when would the tangent be equal to 0? When is the y value 0? At 0 radians or at pi. That's when the y value is 0. So either at 0 radians or at pi radians. What do you have to do next when you square both sides? Extraneous solution. Check it. So go back to the original problem. We're going to check 0 and pi. So we have the secant of 0 plus the tangent of 0 equals 1. Does anybody know what the secant of the angle 0 is? Emma? 1? What's the tangent of 0? 0. We just said tangent of 0 is 0. Does 1 plus 0 equal 1? Yes. So angle 0 is a good angle to use. If we try and use pi, going back up, we have the secant of pi. Remember, the cosine of pi and the secant of pi plus the tangent of pi. So pi is over here. What's the cosine of pi? Minus 1. What's the secant of pi? Minus 1. Does negative 1 plus 0 equal 1? No. So pi is not an answer, just the angle of 0 radians. Number 53 is almost identical, but it uses cosecant and cotangent. But again, that involves FOILing, so you can't just square individual terms. You square the whole quantity that's grouped together. Questions? So we're going to do a word problem today. And the word problem is a roller coaster problem. So we're going to see if we can try and create an equation. And after we have that equation, we're going to see if we can try and answer some questions. So just to get you in the mindset, I thought I'd pull up the Phantom's Revenge.
Oh,
Yeah.
let's go. Hey, wait, what? Is this? No, dude, I'm pretty sure it's Steelers.
Is this the breaking down video?
We're gonna find the height of the first hill, I think, when we're looking at, or the angle of the first hill.
Riding this in 19
This is what I don't like about Phantom's Revenge. It takes too long to get to the top.
Yeah, but then you get to like look at it.
That's true. You get to look at everything. But see, once you get old, the whole looking down thing, I'd rather just like shoot up to the top.
So you like the sky rock?
Yes, 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 I do.
My uncle.
See, look, it's so long.
Yeah, but then you get to look out at.
But that's part of the ride,
But
right?
Wes, you get to see West Smith.
Oh, yeah.
Beautiful sights.
Beautiful sights of West
And like
Smith.
the river, if you look backwards, you can see like the bodies float. The parking lot. And then, oh.
So the second hill is actually the tallest hill, and it goes below ground level into the ravine.
So they don't consider the first climb. Yeah, we'll just go up and down.
I don't think I've ever been in my seat for this one.
Yeah. I'm just like hovering while things are
You know when you were little and your dad would just have
We used to do that with Sadie. Yeah. Does anybody not like roller coasters? I'm sure that like
I don't like. I
yeah.
don't like the initial like drop.
Yes,
like
that
first
whole,
drop.
like-
But then after that, like I could go upside down when I was in a million flips.
It doesn't look like it's very crowded that day.
The best roller coaster
Not a big line.
was definitely at Universal. Like some Harry Potter ride. It's
Ah,
like one of those
haven't
ones.
been there yet.
It's like one of those ones where you sit in it and like your feet dangle. And like we were going like so fast that like you couldn't even move. Like you were like stuck to the seat. Like that's how.
Yeah, that's fast.
I like that.
All right, so if you look at our little word problem, now that you kind of think about the ride at Kennywood, any of the rides, really doesn't have to be Kennywood, but we have the first hill of a roller coaster is 90 feet high and drops to a low point of 20 feet below zero. I think the second hill of Kennywood, I think is 110 feet. And again, it drops below ground level because it kind of goes into that ravine and then through the little tunnel. It says, so it's doing that in a horizontal distance of 210 feet. Sketch and label a figure for this problem, and then confirm and support your answer with graphical, algebraical, or numerical methods. So this takes us back a little bit to last chapter. We are going to make ourselves a little graph and to see if we can come up with an equation. So our goal is to create an equation for the height of the roller coaster. So how high does it start? 90. So you've already taken the little trip to the top. You're now at the top of the first hill, which is 90 feet. That's where it's starting. So we're now at the peak of the hill. It has not crested. You're just like sitting there like it got stuck. And you're lucky you're in the first seat. So it drops to a low point of 20 feet below ground level. So it starts up at 90. Eventually, it's going to go down to negative 20. So those would be my max and min, the highest and the lowest point. It says that it does this in a horizontal distance of 210 feet. So it goes from its max down to the min over 210 feet horizontally. So I'm going to place 210 over here. So my second point, the lowest point, is going to be underneath that 210 because that's the horizontal distance. So we're going to see if we can make a hill. So starting at the top, think of yourself going down the hill and reaching the minimum point. And then again, it just stops. So we have like that first hill, and then something else happens after that. So thinking about trying to write an equation. So go back in your mind. What do we find first? Let's think of A and D. So how would you work through A and D? What is D? What does A mean? What do they mean in the equation or the graph? Yeah, so D is the middle of the graph. That's the sinusoidal axis. So how can I find the middle of the graph? Add them together, divide by. So the D value is the middle of the graph, the sinusoidal axis, the center of the graph. What is D? 25? 45. 35?
Oh yeah, my bad.
There we go. 39 is sharp. So 35 would be the center of our graph. Dylan, once you have D, then how can you find A? Yeah, so the high point from the middle would be A. So Dylan, 90 minus 35. It is a number. 55. All right, the last thing we have to do is find B. So we have an A and we have a D. What is the B? What does that mean? What does that affect? What does it do? The period. So typically the period is equal to 2 pi over B. How much of a graph do we have drawn? Emma? Half. So we have half the graph, so that means our period, since it's half the graph, we would use pi instead of 2 pi. What is the period? How long are we going? What's the distance from where it starts? 2 into 10. So we're going to take 2 10. That's our period, set it equal to pi over b. So b would be pi over 210. It's all coming back to you. So you'll need a calculator. Writing the equation, we have our a, which is 55. We have a cosine graph, a cosine equation. There is no phase shift because you're starting at the top of the hill. And then pi over 210 times x. And then what's the d value? 35. So that's the equation that we're going to use. Questions with getting that equation? Because the period, well, it's actually half the period. From start to stop, from the top to the bottom, is 210. So the distance of the graph. And we're just using pi because it's half the graph instead of all the graph. Other questions? So looking at part B, part B says find the horizontal distance from the top of the hill to the point where the track reaches the ground. Find the horizontal distance. So which letter are we solving for finding horizontal distance? X. X is the horizontal value. So we want to find the horizontal distance from the top of the hill to the point where the track reaches the ground. Doesn't give you a number though. So you kind of have to interpret the number. Emma, what's the number? Why is it 0? Yeah. So we're starting at 90 feet above ground level. Ground level is considered our 0 value. So that means the y is 0. So we're going to plug a 0 in here. Now we're going to use our trig and the algebra to solve for x. So algebraically to solve for x, Hannah, what would you do to get x by itself? Yeah, we'll subtract 35. And then divide by 55. Can we reduce that 35 over 55, or divisible by 5? So negative 7 over 11 is equal to the cosine of pi over 210 times x. And that's where the algebra part stops. So now we're going to use the calculator. In your calculator, we are taking the inverse cosine of negative 7/11. Remember, we're not doing anything with that pi over 210 yet. That's going to change or affect the angle. So using the inverse cosine in your calculator, and maybe we'll go with like 3 decimal places to make it a little more precise. But that number is going to be equal to pi over 210 times x. So whatever number your calculator gives you, that's equal to whatever's with x, because we're solving for x. So, Emma, what number did your calculator give you? Nope, okay, sorry, my fault. Reese, do you have a number? 0.804? Do you have it in radians or degrees? So let's put it in radians. We'll try again.
I got you.
Okay, what do you have, Josh?
I got 2.261.
Okay. Everybody else? Why do we use radians and not degrees? Because it's pi. Yep, that's why we would use radians, because it has a pi. All right, so the last thing, we have to get x by itself. How would you get x by itself? You have pi over 210. Right, so instead of thinking divide, remember you're multiplying by the reciprocal. So we're taking this, multiplying it by 210, dividing it by pi. That number should be a horizontal distance that makes sense. So look at your graph. Does it make sense with where your graph looks like it's crossing the x-axis? Josh, what number did you get?
151.137.
So 151, 131, 137. Sorry.
You're good.
So, yeah, like 151, sure. If it's more than 210, then you did something wrong. But that looks pretty good.
Hold on, I'm getting reports that I'm wrong.
And then the last question says find, or after the front of the car falls a vertical height of 50 feet, what horizontal distance has it traveled? So if it falls a vertical height of 50 feet, now we want to know what horizontal distance has it traveled. What number do you plug in for y if it's falling 50 feet? Emma? You would plug in 40. Why 40?
Because if the top's at 90 and you're dropping 50 feet.
Right, so it starts at 90, you're dropping down 50 feet. So if I drop 50 feet, now we're really at 40. Be careful, you're not necessarily just plugging that number in for y. And then you'd solve the equation the same way. So we take the 35 to the other side, divide by 55. So in the calculator, we're doing the inverse of 111. And then that answer, whatever you get here, you're going to multiply by 210 over pi. And again, it should be less than our previous answer, because we haven't hit ground level, we've only dropped 50 feet. So make sure you're looking and like, does it make sense with the answer that you get? So I think I have 1.4798 here. And is it it 98?
0.917.
Thanks, Gary. Questions? So there is a page in your packet that has 2 word problems on it. You're gonna make yourself a little sketch, like we had here. Find the information, and then at the very back of the packet, there are 4 problems that are solving equation problems. You'll have to use your calculator for 2 of those problems at the back of the packet. You'll have to use the calculator for the word problem. Is anybody interested in trying 2 or 7? Emma, you'll try 2? Reese, you'll try 7? Have a fantastic day. Tomorrow is like a summary day. We're not really doing any notes tomorrow. Just kind of a review day.